Hello all, welcome to KT Semicon self-paced learning module. Now in this video, we are going to start with the discussion of sum of products and product of sums. Let me share my screen. Now basically, in Boolean algebra, a product term is a product of literals or a Boolean variables. And in logic circuits, a product term is produced by AND operation with no operations. This we already know. So a product term is nothing but if I perform AND operation between two variables, then that is nothing but a product term. For example, A dot B, A B whole bar, A B C bar, A B bar, C D bar. These are all my product terms. These are all my product terms. Now, if I perform OR operation between these product terms, then it is nothing but my sum of product. So when two or more product terms are odd, that is Boolean addition, then the resultant expression is known as sum of products. And this is also known as disjunctive normal form. For example, y is equal to bc plus ab bar plus abc bar, or y is equal to b plus ac plus acd bar, ac bar d. These are all known as SOP form of representation, that is sum of product. Now, I have one more representation in my digital, that is nothing but POS form of representation. Now, what do you mean by POS form of representation? That is nothing but product of sum. Now, in the Boolean algebra, basically a sum term is nothing but sum of the literals. So, if we are performing the OR operation between the two variables, then it is nothing but my sum term or Boolean variables. So, in the logical circuits, a sum term is produced by an OR operation with no AND operation involved. For example, A plus B bar, A bar plus B plus C, and A bar plus B plus C bar plus D. These are all my sum terms. Now, if I perform AND operation between this sum terms, it is nothing but my product of sum. So this is how my product of sum is going to look like. So when two or more sum terms are multiplied, then the resulting expression is known as your POS form of representation. Now, how you are going to represent, for example, y is equal to a plus b into c plus d into e plus f. This is how we are going to represent our product of sum expression. Now, standard or canonical SOP form of representation. If each term in sum of product form contains all the variables, then the expression is known as standard sum of product form or canonical form of expression. For example, let's say if I am going to have a function f of a comma b comma c, then let's say this function has an expression ab plus ac plus ab. This is basically represented in SOP form of representation, where this is my product terms. These are my product terms. Now, in the first product term, if I carefully observe, one term is missing, that is C term is missing, and in the second term, B is missing, and in the third term, C is missing. So that's why this cannot be said as a standard or canonical form of representation. If let's say if I'm going to take f of a d m and it is represented as ad bar m plus amd plus amd whole bar. Let's say this is my expression. Now, so this is said to be a canonical or standard form because in each product term I'm basically having all the terms. That's why it is known as a standard or canonical form. That's why it is known as a standard or canonical form of representation. So if your each product term is going to have all the minterms or all the variables, then it is said to be standard or canonical form. If it is not containing all the variables in each product term, then it is known as a normal form. Okay, so here we should be very careful. Now, what do you mean by minterm? So each of the product term in the standard SOP form is called as a minterm. That means, let's say if we are going to have this example f of a comma b comma c is equal to abc plus a bar b c bar. This is this product term and this product term. These product terms are known as my minterms. And this expression is basically in standard form of representation. Let's say if I'm going to take one more function f of a comma b comma c as ABC bar plus AB plus AC bar. Then this particular expression we cannot say this product terms as minterms, because in the definition also they have written that each of the product term in a standard SOP form of representation, those are only known as minterms, but these product terms are not known as minterms because it is not a standard SOP form of representation. So for a n variable function, we are basically going to have 2 power n minterms. A minterm is equal to 1 for only one combination of variables. For example, a bar, a, b bar, c, d bar is equal to 1 for only whenever your a is equal to 1, b is equal to 0, c is equal to 1, and d is equal to 0. Let's say for a 3 variable function, these are the possible minterms which we are going to have. If a is equal to 0, b is equal to 0, and c is equal to 0, then the minterm is known as a bar, b bar, c bar. And this is also written as small m naught. And for the 3 variable functions, we have total 8 number of minterms. So for a 3 variable function, we are going to have total 8 number of minterms like this. From starting from m0 to m7, these are the minterms which we are going to have. A bar, b bar, c bar, a bar, b bar, c, a bar, b, c bar, a bar, b, c. So if you can observe here, if we want to represent 1, we are not representing it in complemented form. But if we want to represent 0, we are representing it in complemented form. Okay. Basically, in SOP form of representation, if you want to represent any variable 0, then you are going to represent it in original form. Whereas if we want to represent 0, then we are going to represent it in complemented form. But if we want to represent 1, then we are going to represent it as it is without any complement. Next, we have something known as sigma notation. Let's say suppose f of a comma b comma c is nothing but a bar b c bar, a bar b bar c plus a bar b c bar plus a bar b c plus e b bar c. Now, this is nothing but my SOP form of representation. And if I want to take the minterms from this expression, then what I'm going to do is I'm going to write down 0, 0, 1, because 0 is basically represented with complement, right? And this is 0, 1, 0, this is 0, 1, 1, and this is 1, 0, 1. So the minterm value here is m1, m2, m3, and m5. So f of a comma b comma c can basically be written as m1 plus m2 plus m3 plus m5. Instead of you writing a bar b bar c plus abc, a bar bc bar plus a bar bc plus ab bar c, you can simply use the minterms m1 plus m2 plus m3 plus m5. Or else we can use sigma notation for representing it. We can simply write f of a comma b comma c as sigma m 1 comma 2 comma 3 comma 5. So these are the representations which we can follow for representing any SOP form of expression. Okay, you can either use sigma notation, or we can either use the minterms notation, or else we can write it down in a normal SOP form of representation. But here we need to remember that if we want to take any minterm, then we always need to consider a standard form. That's it. Now, so this is what here we have seen in our example. Now, coming to standard or canonical POS form of representation. Now, in the case of standard or canonical form of representation, if each term of product of sum contains all the variables, then the expression is known as a standard POS form of representation. So, if your POS form of representation, if it needs to be said as a standard form, then each particular term should have all the variables which should be present. For example, if we are going to have f of a, b, c, then it can be written as a plus b bar, a plus b plus c bar into a plus b into a plus c bar. This is my POS form of representation, right? And but it is not said to be a standard POS form of representation, because in the second and third term there are missing literals. That is, in the second term we are missing c, and in the third term we are basically missing b. So that is the reason it is not said as a standard or canonical form of representation. Next, we have something known as max term. Now, what do you mean by max term? So the max term Here, each term in the standard SOP form of representation is known as a max term. For example, if we are going to have a function f of a comma b comma c, which is nothing but a plus b plus c bar into a plus b bar plus c into a bar plus b bar plus c. Now, here this term and this term, each individual terms are known as my sum terms, or these are also known as max terms. Okay, so this particular terms in each particular term is known as your max terms. Now, you can only consider your max terms from a standard POS form of representation. For example, if I am going to have f of a comma b comma c, which is equal to a plus b into a plus b bar plus c bar into a plus c. Then from this, I cannot take my max terms directly. First, I need to convert it into standard form. Then only I can consider my max terms from this expression. So max terms can also be represented by capital notations where the subscripts denote the decimal equivalent of the binary number of the max term. For example, this is the best example which we can take for a max term. So 000 can be written as a plus b plus c. You can see here for representing my 0, I am not writing it in complemented form, but I am writing it in its original form. But for representing my 1, I am using a complemented form. For example, if I want to represent 0 with a variable, then I am going to use simple a. But if I want to represent 1, then I am going to represent a bar. So in the case of your POS form of representation, you are going to use complement form for your 1, whereas normal form for your 0. So these are the variables which we have, and a plus b plus c is nothing but my m naught. We are going to use capital M naught. Okay, so for 000 we are going to have m naught, m1, m2, m3, m4, m5, m6 and m7. So these are nothing but my standard POS form of representations. And we can also use this pi notation. For example, if I'm going to have f of a comma b comma c is equal to m naught dot m4 dot m6 dot m7, you can represent this as a plus b plus c into a bar plus b plus c into a bar plus b bar plus c into a bar plus b bar plus c bar. Or else you can also use pi notation for representing them as 0, 4, 6 and 7. So this is how you can represent your standard POS form of representation. So that's all about this particular session where we have introduced you to SOP form of representation, POS form of representation, standard POS form of representation, and standard SOP or canonical form of representation. Thank you.